Hello, everybody, and welcome back. Welcome back. We're on question number 11 from our Alberta math contest from the 2017-2018 year. So, the area of the quadrilateral bound by the graphs of the functions y equals x minus a in absolute value, and a is something between 0 and 4, and y is 2 minus the absolute value of x minus 2 is 15/8. The smallest value of a is. All right, let's see if we can visualize this. Because it's probably a good idea to visualize this. Now, with absolute values, there's a fair amount of possibility of right angles here. You go in and out at 45 degrees along the x-axis. Now, if I wanted x minus a, then wherever the heck a is becomes my new 0. And so we just sort of shift along like that. So this, for example, could be x minus 4. Y equals x minus 4 if 4 were here. Okay? And now, what are they talking about? They're talking about, well, first x minus 2. Right? So put a 2 here. But then it's 2 minus that. So what's going to happen? Well, this will flip up, but first let's do minus. So minus just flips the whole thing down, and then you add 2 to both sides, you move up by 2. Okay? So that just gives me a general idea as to what's going on. Now, so we'll put 1 here, 2 here, 3 here, 4 here. So a is somewhere in this range between 0 and 4. So 1, 2. We'll give it a bit more space. So we'll say 1, 2. 2 up here, and then if you plug in 0, you'll get 0 minus 2 is negative 2. In absolute value is 2. So you got a nice little sort of triangle going up like that with 45-degree angles here. And then we have a somewhere in here. Doesn't matter where. But again, you get a bunch of 45s, you get a 90 here, so you'll get some 90s here as well. Okay, so we do actually have a rectangle. And we're told that this rectangle, they just called it a quadrilateral, but it's a rectangle for us, has an area of 15/8. Now, how can I figure out what a should be from here? Well, we know that this point up here is going to be 2, 2. We know that another coordinate is a, 0. But what about these two over here? Now, before I keep going, a is between 0 and 4. Yeah, okay, that's what I thought. We want the smallest value of a, so we want the value of a that's furthest over here. So you could actually get another value of a. I think 4 minus a would work. And it would get you the same quadrilateral but pointing in a different direction. We don't want that. We want the smallest value of a, so we want it over here. Okay, well, if I knew this side and this side, we'd be all set, because if I could get them in terms of a, then we could just multiply them together and get 15/8. And we'll probably get some quadratic in terms of a. Now, the question is, well, what exactly can we do? Well, if this is a 45-degree, and this distance from 0 to a is a, then this must be a over root 2. Right? Because we're just using the isosceles right angle triangle, and if you know the hypotenuse is x, you get x over root 2 for each of the sides. So we get a over root 2 here. Okay, and an a over root 2 here. Now, what about the big side here? Well, we know the hypotenuse of this big right angle triangle is 4, so each of these sides should be 4 over root 2. But part of this is a over root 2, so this should be 4 minus a over root 2, and that should do it. So my quadrilateral, which is just a rectangle, has one side a over root 2 and the other 4 minus a over root 2. Okay, and so their product is something we know. They told us the area is 15 over 8. So the root 2's turn into a single 2. Let's multiply both sides by 8. So we'll get 15. We'll get 4 times a times 4 minus a over here. So multiply through, you'll get 16a minus 4a squared is equal to 15. And yeah, it's a quadratic. 4a squared minus 16a plus 15 equals 0. And so where do we go from there? Well, we could try and factor it. I'm not sure how well this will go. Actually, we could check what our possible answers are. So shouldn't be unreasonable to do it. Seeing a lot of 2's there, so maybe 2a and something, and a 2a and something. And with a 15 there, I'm thinking maybe minus 5, minus 3. Minus 5 and minus 3 is minus 8, and then times the 2's should be the minus 16. So that looks good. So either a is 5 halves, or a is 3 halves, and we want the smallest a. So 3 halves it is. So not bad, as long as we're able to sort of sketch these absolute value curves. Not bad at all. Because we realized, oh, it's a rectangle, and then, hey, there's a bunch of isosceles right-angled triangles, and we get ourselves an answer of D. And there we go. Okay, so that was question number 11, and we're going to move right along to question number 12, and I'll see you for that in the next video. Take care and have a wonderful day.